Hey, we're going to start talking about limits. We're going to introduce the concept. Limits are a little bit different than anything you've probably ever done in math before. We'll start off with the definitions and notations, and we'll work some with graphs, and then we'll go to functions algebraically in the next section. But let's see here. What do we got? We've got the limit of a function. Okay, our function is going to be f of x. Is the output value you expect. Notice I've got that word capitalized. Expect to get as you approach a specific input value. Okay, as we get going, that will make a lot more sense. Okay, but it's the output you expect to get as you get close to a specific input. So when we say expect to get, it doesn't necessarily mean it's the actual output. And when we say approach a specific value, it doesn't mean we're actually using that value. So things are a little bit off sequence here as far as exactness. Limits are exact, but how you get them is not your traditional algebra way up to this point. So let's look at the notation. We've got three different notations. Limit as x approaches a, which is what we have down here at the bottom, of f of x. So we're just saying the limit as you get close to the x value of a, so following it across the x-axis of the graph of f of x. The limit of that will be L, which is a real number. Now when you see this, just the way it's written with a number down here for a, it's considered a two-sided limit, which means you have to approach it from both sides. Okay? That means coming at it from the left and coming at it from the right, because if you think about when I say approach something, you can approach it from different sides if you want to get close to it. We have another definition here, and it says the limit of f of x as x approaches a with a little superscript positive up here. That means from the positive side. It means you're going to approach a from the right. Okay, so you don't have to look at both sides of the function or both sides of the number. You're just looking at the right side. Okay. The last one here, limit of f of x as x approaches a with a superscript negative sign up there. That means from the negative side or from the left. So the two that have the positive and negative on the a, that doesn't mean that the a value is positive or negative. That tells you which way you're approaching it from. So you can get close to 0 from the left side or the right side. And that's what the positive or negative does. Those are one-sided limits, and they'll always be listed that way. If it doesn't have that, it's considered a two-sided limit where you have to approach it from both sides to ensure you get the right thing. Okay, so let's see if we can do this with some graphs very quickly. So I've got a graph of a parabola down here with a point missing, but it says the limit as x approaches 3 from the positive side. So that means I'm going to take and follow my graph from the right-hand side up to where x is 3. So x is 3 now right in here, but I'm following the graph from that side. So if I follow that, it's a little hard to tell what's going on, but as I get closer and closer, I see this hole as I get close to x equals 3 from the right-hand side. Well, there's no reason I wouldn't expect to hit that hole. Okay, so the expectation is that I'm going to go exactly where that hole is. So forget that there's a hole. I'm actually never touching 3 when I talk about the limit. I'm talking about getting close to it. So coming in at 3.5, 3.1, 3.01. But anyway, as I follow it from the right-hand side, this y value looks to be about 1/2 in here. So that will be my limit. Coming at 3 from the right-hand side, it looks like I'm going to hit 1/2 as an output. Coming at it from the left-hand side, okay, let me color coordinate some things here. Coming at it from the left-hand side, it looks like the same thing. So I'm coming at it from the left-hand side, so I'm using numbers less than 3. 2.9, 2.99, 2.9999. Once again, it looks like I'm coming toward 1/2. Okay, so the fact that I'm coming at that from the left and the right and getting the same thing guarantees me I have a two-sided limit. And when I say limit as x approaches 3, that gives me 1/2. Okay, so the idea is that we can't have one person walk in from the right and another person walk in from the left and expect different things. Independently they can, but when we get to the two-sided, it must match. Okay, so if the left and right don't match, the two-sided doesn't exist. Now, the thing that you know from old algebra class is f of 3, the function value when x equals 3. Looks like this point that's been placed way up here at y equals 3. Okay, so let me see. Let's do a different color. So that point up there is the actual function value, is what we're talking about. So function values don't have to match limits. So let's go to the second graph and talk about h. So over here we're trying to approach -3 from the positive side. So here's -3, so we're going to come at it from the positive side, and it looks like the height of that graph would be 2. Now the next thing is to approach -3 from the left side. And if I approach it from the left hand side, it looks like the height will be 6. Okay, so I'm coming in from the left hand side, getting close to where the x would be -3. Alright, now the two-sided limit approaching -3. Well, Bobby said he got 2 when he walked from the right. Anna says she got 6 when she walked from the left. So they're not going to the same place. So the expectation must match for the two-sided limit to exist. So we're going to say does not exist. And that's because left does not equal right. In this case, they're not going to the same place. Okay, so when we try to talk about it, we wouldn't get the same answer. The last part here, h of -3, well, that point is way down here, and that value is actually the 2. Okay, so just kind of take a good look at that and think about it for a moment. Okay, we're coming up from the right hand side, the left hand side, and then we're asking if they match. Okay, let's go to the next set of problems. Okay, so we got another graph here. Let me try and get everything on here at one time. I don't know if I'll color coordinate this very well because why won't it move? There we go. Because I'm going to ask so many questions, but let's see here. I'll do my best. The first one, limit as x approaches 0 from the right. Okay, 0 from the right. So if I come at x equals 0 from the right, it looks like I'm going to hit a height of 3. If I come at 0 from the left, it looks like my height is going to be 0. Okay. Next question in this list, if I come at -2, and that's a two-sided limit, so -2, there's no break, no hole here. It's nice and continuous. So if I come at it from the left, it looks like 0. If I come at it from the right, it looks like 0. So that two-sided limit looks like 0 because it looks like I'm getting the same thing from the left and the right. Okay. The next one, as I approach 5, where's 5? Over here. That's a two-sided limit. And as I look at over here where 5 is, coming at it from the left, it looks like I'm going to hit 3. Coming at it from the right, it looks like I'm going to hit 3. Very different approaches, but they're approaching the same point. So in that case, it looks like the limit is 3. Next couple of questions here. F of -3. Well, let's find -3. -3 is over here. This is the actual function value. There's an open hole, so it does not exist. So when you look at this graph, there's no value assigned to when x equals -3. There's not even a dot somewhere else. F of 2, if I come over to where x is 2, I look down here, it looks like the function value is -1. That's the height there. Okay. Next thing here, limit as x approaches -3. That's a two-sided limit, so I come over to -3. There's a hole at -3, but when I come at it from the left, it looks like 2. Come at it from the right, it looks like 2. It might be a little bit more than 2. I'm just going to go with 2. The next one, x approaches 2. Right here in the middle, there's a hole, but coming from the left, it looks like 1. Coming from the right, it looks like 1. So 1. Approaching 0, the two-sided limit. 0 is in the middle here. The two-sided limit, well, from the left was 0 and from the right was 3. They don't match, so that does not exist. And approaching 6. Now the limit has to be a real number. We have to be able to say exactly what it's going to. So when I look at 6, x equals 6, I see an asymptote, and it's just going down on both sides forever. So since that continues to go down, that's not going to give me a number. Okay? I don't even expect there to be anything there because it keeps going to negative infinity. So they don't match, so that is, does not, well, they do match, but they're not an actual number, so that does not exist. And again, in the middle, f of 0, the actual function value is, when x is 0 is 3. And f of 6, the actual function value when x is 6, looks like does not exist. Okay, so keep that in mind. We've got left limits, right limits, and two-side limits, and then we also have function values, which are old news from days gone by. All right, thank you.